Hey everybody, this is Mr. Munson. We're in Unit 4, Congruent Triangles. This is the vocabulary video, so this is a really important video. If you don't get this, you don't get it. Here's the thing, when you talk to most students who do well in geometry, it's because they understand the vocabulary words. So if you want to turn it up a notch, if you want to understand what the students who are getting grades better than you, or you want to even take it up to you're doing well, but you want to take it up to the next notch, understanding the vocabulary words is key. So let's do this video and let's get started. All right, now keep in mind that you have to now start writing your words on the flip side of this. I don't want to see anything written where I write it. I'm writing it here because it makes sense in the video. You should be writing it on the back so that you can fold along this red line here. You just fold your paper backwards, write it on the back, and it becomes a study guide for you. You can pull that piece of paper back because you've cut it, and you can look at the blank and go, and blank triangle is a triangle whose angles are the same, right? And you have to think through the word, okay? So make sure you're doing that. If I pick up or collect your vocabulary words or take a look at it and you have your words written in here, I will not give you credit, okay? Warning given. Okay, so the first one here, basically a triangle that has three angles that are all identical. It's an equiangular triangle, and they have to be 60, so it'll always be a 60. So what we find out is that equiangular triangles are triangles whose angles are all the same, and they'll be 60 degrees. You just know that from now on until the end of the year, okay? Now, what's really cool about equiangular triangles is that the sides also end up being the same. Now, you know that as an equilateral triangle. Now, I'm going to move through this video, but when you go to study your vocabulary, you want to read these kind of notes. I just talked it through. There might be some additional information here you want to know. This is the fact. This equiangular triangle, which is also an equilateral triangle, which is something that you're hopefully used to before you get in the class, because the angles are congruent and the sides are congruent, we know that's a regular polygon. Okay? All right, let's move on to the next. So before I just go through this, I want you to look through the rest of this page and see if there's any words or phrases that you can go ahead and bring the words in on your own, your previous knowledge, if you will. Like the next one's pretty easy. What do you call a triangle that has a right angle in it? So I want you to go ahead and see if you can do the rest of this page and identify what the names of the figures are based on either their angles or sides. Just read through the thing and fill it in. Put the word on the opposite side. Okay? Put me on pause, and then we'll come back and we'll run through it. I would rather you try it on your own first and then copy me, okay? Let's give it a pause. Okay, the first one's a right triangle, and basically a right triangle is a triangle that has a right angle in it. Pretty easy. Here's where the right angle is, right? All right, so the other two angles, this one here and this one here, have to be acute angles, less than 90. Pretty easy stuff. Now, if we look at the writing, there, it says write the letters A, B, and C in the corners, the vertices of the triangle, so that A is across from side A. So here's side A right here, right? So I'm going to go across from it and find the angle that would make it right there, okay? So I want you to do the rest. B is across from the side B, and so on. Go ahead and do that, and then put me on pause and come back and check to see if you did it correctly. No worries if you did that wrong, right? Just erase it and fix it. If you waited for me to write it in there, you were showing the signs of somebody who's scared about being wrong. And I don't want you to be scared about that. That's why you write in pencil, erase it. But if you get it right, you thought it right, and now you own that thought. If you're just simply copying down when I tell you to put it on pause, that is a clue of why you are not succeeding where you want to be. And if you're not willing to change that, just understand you're going to get the same results, and that is struggle. I don't want that for you, and I think you deserve better. But it's up to you to change that. Let's move on. All right, don't worry about the right-hand side. But anyway, we have an obtuse triangle is the next one, and the obtuse triangle has an angle that's at least, it only has one and only one that is over 90 degrees. The other ones are called acute angles, or less than 25 or less than 90. Now, I realized after I created this thing that I forgot an important triangle that we would classify by the angles. And so what I want you to do is I just want you to simply create some notes over here. This is the example of an acute triangle. An acute triangle is a triangle whose three angles are all acute angles. Okay? So you write those words in your own. If you didn't hear them or you didn't understand it, put me on pause, rewind, and hear me say what an acute triangle is, then write the words down. All right, let's move on. So the next one is an equilateral triangle. An equilateral triangle is a triangle where all the sides are congruent. Okay, that's pretty easy. So in an equilateral triangle, you can see that, like I say, that all the sides are congruent. And so the next one is an isosceles triangle, and that's one where you have two sides that are congruent. Okay? And basically, we want to make sure that we identify in the picture our understanding of what legs and base angles are. So study that drawing. So, the triangle could be turned, but in any case, if I have two sides that are congruent in a triangle, then that's an isosceles triangle, and the angles opposite them, that one for that side, and that one for that side, are the base angles. Okay? Now, they're not the base angles because they're at the bottom, because the triangle might be turned on its side. The definition of base angles is that they're opposite the legs. So you have to find the legs and then point to those angles. Let's move on. All right, and last but not least, a scalene triangle is a triangle whose sides are all different. So in this case, there's no sides that are congruent. Okay? So here's an example of that, right? Here's a triangle that none of the sides are congruent, so that's what makes it scalene. What's kind of interesting, you'll love this, is that across from the largest side, opposite it is the largest angle. And across from the smallest side is the smallest angle. And of course that means the medium side, there's a medium angle. It's pretty cool stuff. You can put that in notes if you want. So next up we have remote interior angles. So remote usually projects the idea of something far away. And these are interior angles. So remote interior angles are in reference to a corresponding exterior angle. So suppose I draw a triangle and I extend one of the sides to create an exterior angle. That angle has two remote interior angles. That's 1 and 2. Okay? And we use R1 and R2 to identify those. Okay? Now, let me draw a picture over here to the left, or to the right, and put me on pause, and you identify by putting R1 and R2 in there, what are the two remote interior angles that go with that exterior angle? There you go. Now you might have put R1 at the top and R2 at the bottom. It really doesn't matter which one's which. It doesn't matter. They're both remote interior angles. I did that to kind of scramble it up a little bit and create in your mind the idea it doesn't matter. But where it's not is here. That one's linear to this equation. So it's the remote, and that means far away from that exterior angle. Now we're going to discover in one of the lessons that there's actually a relationship between that exterior angle and those two remotes, meaning I can write an equation to solve for one or the other depending on the information given. Let's move on. Now this next thing is more of a concept than it is a vocabulary word, but it's an idea that I want to make sure that you understand as we move forward. Two polygons are congruent, and of course triangles are polygons, if and only if their corresponding sides and corresponding angles are congruent, okay? All right, so just check to make sure you have sides and angles there. Your printout might have the word sides in both places. Just fix that right now if you do. Okay? So basically, I look at these two triangles and I have to ask myself, are they congruent to each other? To do that, what I'm going to do is I'm going to make sure that the left side has three sides that match the three sides in the right one. And I need to check to make sure that there's three angles over in the left one that matches the three angles over in the right one. Okay? Now there's a little bit more to this, but right now in the very basics, we want to make sure of that. Okay? So if you look below these two triangles, I have some congruent statements that are not complete. And I want you to just take a few seconds and look at the congruent statements for the segments and the congruent statements for the angles just below here. I want you to fill in the blanks. Look at what the information is given and then find the piece in the other figure that matches. Use your congruence marks to check that. Put me on pause and come back and check your work. All right, there you have it. So hopefully you had DE sitting in this spot, DF in that spot, BC in that spot, angle D, angle E, and angle F. And it was basically you just confirming what was in one drawing matched the other by the congruence marks. Very simple. Now these are the corresponding sides and the corresponding angles, okay? So, and the corresponding angles, or the corresponding sides have to be congruent to each other, okay? All right, very good. The next one that we want to look at is corresponding parts. Again, let me remind you, if you've been writing stuff in other than, say, here, you should be going back and erasing your main entries, what the word is, the vocabulary word for that main section is, and putting it over on the other side of this paper. You should have the paper folded right here and then covering over most of your vocabulary words. Okay? All right, and then that way you can flap back and forth and test yourself. Corresponding parts of congruent figures, right? So that we just kind of talked about corresponding parts there just above us. Okay? Corresponding parts of congruent figures are the parts that are congruent from one figure to the other. For instance, in the box above, you should have identified A is congruent to D because those angles have the same congruence marks. Angle A corresponds to angle D because of this, as does the side AC corresponds to DF. Now, if that just flew through the window for you, put me on pause, read that very carefully, analyze with the drawing above, and when you feel like you've got that, then you move on. All right, let's just take a quick second and see if you can identify these real quick. You might have seen the answers, but that's okay. See if you can do it on your own. What side in the figure above is opposite to angle C? And then what angle is opposite side, sorry about that big bell, what angle is opposite side F? Okay, or side FD. Put me on pause, and then let's check our work. So we're looking at what side is opposite angle C. It's very easy. You just point to it with an arrow like this. Remember, it's basically, it comes down to, it's the only side that has nothing to do with forming angle C, right? Now, when we were looking at FD, side FD, that's this one here. And you look at the angle that is opposite it. Basically, it's the only angle that has nothing to do with that side, right? Angle D and angle F all include this side in the building of them. Okay, so the angle that's opposite that side has to be the one that doesn't have anything to do with it. All right, so we'll go ahead and put those answers in. Now, something tells me I might have just mixed up those words, but I think you understand what I'm saying. If I didn't, fantastic. Let's move on. All right, don't worry about this stuff over here. All right, very good. So, and this stuff we'll just take right over here, pull it out of the way. All right, a congruent statement is a statement that has a congruence mark, not an equal sign. Equal signs make equations. Congruent statements have a congruence mark in it, okay? So a congruent statement is a statement that states two figures are congruent, and the order of the letters that identify these triangles are congruent. The order identifies which parts are corresponding to each other. Here's a congruent statement for the above figures, that A, B, C, and then that triangle D, E, F. When writing the congruent statement, order matters. So if you look up at the triangle ABC, I'm saying it's congruent to DEF. And if you don't hear anything today in this vocabulary but this, I need you to understand this. I write the left-hand side, whenever I'm dealing with triangles or polygons, I always write the letters in alphabetical order. But that doesn't mean this side will be in alphabetical order. It happens to be DEF is in alphabetical order, but that's not how I chose to write the letters over there. What I did is I looked at the angle A in the figure above, and I looked to see which angle was congruent to it, and I put it in this first spot. Then I found the letter B, and it was the second letter, and I looked up there to see what angle was congruent to it, and it was the second letter, and so on. That's how I actually created it. Now, I'm going to be ingenious enough to tell you that I want this side to be in alphabetical order, and that might create letters over here that are not. And you have to be thinking that through as we go through these problems later on. And then finally for this page, CP, CTC, which is a series of letters that you're going to have to memorize. And it's not so bad. Every other letter's C. That's easy enough. And then you have a P and a T, and they both rhyme with C. So that's easy enough. CP, CTC. But you also have to memorize what the letters mean. It basically means corresponding parts of congruent triangles are congruent. Okay? And so if two triangles are congruent, then their corresponding parts are congruent. It's easy enough. All right? But we'll kind of study that a little bit more as we go through that concept in a video. Now, what I want you to know is up to this point, in order to show two triangles are congruent, you have to show 3 sides in the first triangle match 3 sides in the second triangle, and the 3 angles in the left triangle have to match the 3 angles in the second triangle, okay? And so that's the long way. So you have to show 6 pairs of things are congruent to show triangles are congruent. What I want you to know is that as we end up this unit, we're going to find some shortcuts. Instead of having to show 6 things match up, I'm going to be able to say to you there's some shortcuts. And all we have to do is find 3 things in the left triangle that match 3 things in the right triangle. And if that's so, it forces the triangles to be congruent. And these are the shortcuts I want you to understand. The first one is this one. Side, side, side. Now, congruence shortcut is known as AKA SSS. And to summarize what this is about is 3 pairs of sides are congruent. 3 pairs, that means 3 sides in the left correspond and are congruent to 3 sides in the right, okay? So 3 pairs of sides. Here's pair number 1, pair number 2, and pair number 3, okay? If that happens, then we get to conclude the triangles are congruent. No longer do we have to show 6 things, we can just show 3 things. That's cool. Now what I want you to do is put me on pause and see if you can do the rest of these. HL, don't worry about it, okay? But do the next few and see if you can identify what the letters represent. It's pretty easy. Don't forget to write the AKA and then see if you can summarize it by looking at the picture. No worries, write in pencil. If your summary is great, then use it. If it's not, you like mine better, then you'll erase yours and put mine in that place, okay? Put me on pause and see if you can do it on your own. All right, let's see how you did. Okay, so angle, side angle is the next one, AKA ASA. And summarize, it's basically 2 pairs of angles congruent and a pair of included sides. The side is trapped between the 2 angles. It's very important. The sides are trapped between the 2 angles, okay, for this scenario, this shortcut to work. So I have 3 things again, a pair of angles, a pair of sides, and a pair of angles. The sides are trapped. And if I can prove that, then the triangles are congruent. Let's move on to the next one. All right, here we go. Angle, angle, side, AAS, AKA AAS. Summarize, you have 2 pairs of angles that are congruent, just like the previous one, and a pair of sides where the sides are across from the same angle, okay? So it's really important. So if you look at the figure, I have a pair of angles. I got 1 strike and a 2 strike in the left, and I have a 1 strike and a 2 strike in the right. And the side that's showing congruent is across from the same angle as the one on the other side. If for some reason this side right here was actually across from that single stroke, this game can't be played with this shortcut, okay? So make in mind that it has to be across from the same angle, okay? Okay, we're almost done. We have 2 more, really 3 more to do real quick. Side angle, side. So it's a pair of congruent sides and a pair of included angles. Now, I must tell you that your drawing might be a little bit different than mine. I need you to fix it, okay? So I'm going to zoom in on this so that you can fix the drawing. Maybe put it over here because I have a drawing where yours is at already. So this is the figure that should say if AB is congruent to DF and so on, okay? This is angle A is congruent to angle D and so on, okay? And so draw this picture in, and then we decide that angle or triangle ABC is congruent to DEF, okay? Let's go to the next one. Okay, before we get too far into the next one, check to see if your drawing for this HL one is written in there properly. If not, draw it off to the side, scratch through this drawing, put the information into yours, and let's get going. Put me on pause if you need more time. Okay, and so this one is hypotenuse leg, and its AKA is HL. It's basically a pair of hypotenuses, or hypoteni, and a pair of legs that are congruent, okay? All right. The last thing is, I would, if I was you, if I have a highlighter, I would highlight this right here. These are 2 very common shortcuts students use, and they do not work for congruence. This is an obvious one that you don't want to use. And then this one here, meaning that if I have 3 angles in one that match 3 angles in another, then some people would conclude that the triangles are congruent, and that's not one of them. The only shortcuts that we can use are the ones above. These 3 shortcuts do not work. If you use them, you will lose the points. All right, that's it. Fantastic. Again, a rather long video for such a quick set of vocabulary words. The cool thing is, you have no do-it problems. You've already done your work. Okay? So close it up and